this module, you will learn about the properties of inverse trigonometric functions. Before we begin a discussion on the properties of inverse trigonometric functions, let's quickly revise what you have learned so far. If sine inverse x is equal to y, then sine y is equal to x. Also, sine of sine inverse of x is equal to x, where x belongs to a closed interval -1, 1. Similarly, sine inverse of sine x is also equal to x when x belongs to a closed interval -π/2, π/2. You also learned about inverse trigonometric functions and their principal value branches. Let us now prove some properties of inverse trigonometric functions. The first property states that sine inverse of 1/x is equal to cosecant inverse x. Also, cos inverse of 1/x is equal to secant inverse x. Similarly, tan inverse of 1/x is equal to cot inverse x. Now, let us prove that tan inverse of 1/x is equal to cot inverse of x. Denote cot inverse x by y, which implies that x is equal to cot y, or 1/x is equal to tan y. This further implies that y is equal to tan inverse of 1/x. Finally, substituting the value of y proves the result. Similarly, the remaining two properties can also be proved. The second property states that sine inverse of -x is equal to minus sine inverse x. Similarly, tan inverse of -x is equal to minus tan inverse x, and cosecant inverse of -x is equal to minus cosecant inverse x. Consider the second part. Let us denote tan inverse of -x by y. This implies tan y is equal to minus x. It can also be written as x is equal to minus tan y, or x is equal to tan of minus y. Now, tan inverse of x is equal to tan inverse of tan of minus y. This implies tan inverse of x is equal to minus y, since tan inverse of tan theta is equal to theta. Substituting the value of y gives tan inverse x is equal to minus tan inverse of minus x. On multiplying both the sides by -1 gives the result, that is, tan inverse of minus x is equal to minus of tan inverse x. The other two properties can be proved in a similar way.